Here we want to find the integral of 4x squared plus 14x plus 9 dividing by x plus 2 to the third. So first we need to decompose this quotient right here. X plus 2 to the third is called a linear repeating factor. Is a repeating linear factor. So x plus 2 is a linear factor. And so when we have a repeating linear factor like x plus 2 to the third, then we have to write it as x plus 2 to the first, x plus 2 to the second, x plus 2 to the third. Because x plus 2 is a linear factor, so the top we just need a constant. Here we just have a constant and then a constant. And then if we look down here, the common denominator is x plus 2 to the third. So we need to multiply this quotient right here, this fraction, by x plus 2 squared over x plus 2 squared. Multiply this fraction by x plus 2 over x plus 2. And now all denominators are x plus 2 to the third. And so we have a times x plus 2 squared, b times x plus 2, and then plus c. And so now we have 4x squared plus 14x plus 9 is equal to all of this. X plus 2 squared is x squared plus 4x plus 4. Multiply, we get 8x squared plus 4x plus 4a plus bx plus 2b and plus c. Here we have 8x squared. This term has x, this term has x, and so we can rewrite them as 4a plus b times x. And then we have 4a, 2b plus c, and these terms are no x. And then now we just need to match corresponding coefficients. So the coefficients of the x squared will be 4 is equal to 8, 14 is equal to 4a plus b, 9 is equal to 4a plus 2b plus c. A is 4. From this equation, we can find b. 8 is 4, so we would replace a with 4, and then solving for b, b is negative 2. And then use the last equation here to find c. So in the place of a, we have 4. In the place of b, we have negative 2. Solving for c, we get c is negative 3. And so the partial fractions will be 4 over x plus 2, negative 2 over x plus 2 squared, and negative 3 over x plus 2 squared. And then now we need to integrate each one here. The integral of 4 over x plus 2 is 4 times the integral of 1 over x plus 2. Let u be x plus 2. du dx is 1, so du is dx. And so now we have 4, and then this is u, so it's 1 over u. Dx is just du. record that the antiderivative 1 over u is the natural log of the absolute value of u. But u is x plus 2, so we get 4 times the natural log of the absolute value of x plus 2. So that's for this integral. And now let's go to the second one. So we have, this is the same as negative 2 times the integral of 1 over x plus 2 squared. Again, let u be x plus 2, du dx is 1, so du is equal to dx. And so the integral now becomes 1 over u squared. So this is u. 1 over u squared is the same as u to the negative 2. Antiderivative of negative 2, add 1 to the exponent, so negative 2 plus 1 is negative 1, and then divided by negative 1. Negative 2 times negative 1 is just 2. Negative 2 dividing by negative 1 is just 2. And then u to the negative 1, if we move it to the denominator, then it becomes u to the first. So we get 2 over u plus 2. And then similarly, for the last integral, negative 3 over x plus 2 to the third. Also let u be x plus 2, and we get du as dx. And so this integral becomes negative 3 times the integral of 1 over u to the third, which is u to the negative 3. Add 1 to the exponent, we get negative 2, and then divide by negative 2. Negative dividing by negative is positive, and then move the u to the negative 2, move it to the bottom. So we end up with 3 over 2u squared, which is 3 over 2 times x plus 2 squared. And so in summary, the original integral is equal to this.